Hello everyone, welcome back to the Microservice Masterclass. In the previous episode, we discussed asynchronous communication using Kafka and RabbitMQ, and we learned how a producer sends messages through a broker without waiting for consumers. But asynchronous communication is only a communication mechanism, right? Event driven architecture, or in short, it is called EDA, is a broker architectural. It is a broader architectural style in which important business events drive the behavior of entire system. So in this video, we will understand what event driven architecture means, event versus command versus messages, producer, broker, and consumers, event notification, event carried state transfer, choreography versus orchestration, and a complete order processing example. So let's begin. What is event driven architecture? An event represents something important that has already happened in the system. Once again, what is an event? An event represents something that happened already in the system. For example, order created, payment completed, inventory resolved, order shipped. All of these actions are happened in the past, right? Suppose a customer places an order and the order service store the order and publishes an order created event to event broker. The payment service consumes it and processes the payments. The inventory service reserves the products. The notification service sends the confirmation. The important point is that the order service does not directly call all these services. It simply announces that an order has been created. Any service which is interested in this event can react independently. If we later create an analytic service, we can subscribe it to the same event without changing the order service. This gives us a loose coupling. The producer does not need to know how many consumers exist, where they are deployed, which programming language they use, and how they process the event. This independence helps services to scale and evolve separately. But loose coupling does not mean zero dependency. All consumers still dependent on the meaning and the structure of the event contracts. Therefore, event schema must be designed carefully. Now let's see the next point. Event versus command versus message. The terms event, command and message are often used interchangeably, but they have different meaning. What is an event? An event describes something that has already happened. What is an event? Event describes something that is already happened. For example, order created, payment completed, customer registered. All of these things are an event, right? A producer is not telling a particular service what it must do. It is announcing a completed business change. Multiple services can react to the same event. Clear? Next is command. What is command? A command asks a specific service to perform an action. What is command? A command asks a specific service to perform an action. For example, create invoice, resolve inventory, send notification, email. A command represents an intention. It normally has one logical receiver and it may succeed or fail. The difference became clearer with this example. Order created means an order has already been created. Create order means something is requesting the order service to create one. Events describe the past, command request future action. Now next is message. A message is general data package transported between the system. Both events and commands can carry a message. Think of a message as an envelope. The content inside the envelope may be an event, a command, or some other information. So every event sent through a broker is a message. Every event sent through a broker is a message, but every message is not necessarily an event. This distinction helps team design system with clear intent. Clear? The next is core components. An event driven system has three main core components: event producer, event broker, and event consumer. What is event producer? Event producer detects or perform a business action and publishes an event. For example, after storing an order successfully, the order service publishes an event. Order created. The producer should not publish an event before the business transaction succeeds. Otherwise, consumers might process an order that does not actually exist. Correct? Next is event broker. The event broker receives, stores, and distributes events. Kafka, RabbitMQ, Amazon, EventBreeze, and similar technologies can play this role depending on the requirement. The broker separates producers from consumers. Instead of order service directly communicating with inventory, notification, and analytics, it produces one event to the broker. Okay. Next is event consumer. The consumer subscribes to relevant events and perform their own work. The inventory service reserves the stock. Notification service sends an email. Each consumer can process the event at its own speed. If the notification service is temporarily unavailable, the other consumers can continue working. This isolation is one of the major advantages of event-driven architecture. What is event notification? Next point is event notification. There are different ways to design an event. The first approach is event notification. In this pattern, event contains only enough information to notify consumer that something happened. For example, event type and event ID, or maybe order ID. Like event type is order created and order ID is 501. For example, the inventory service receives this event, but it also needs the product detail. Therefore, it calls the order service using an API like get orders 501. The advantage is that the event remains small. The order service continues to be authoritative source of order information. The order service continues to be the authoritative source of order information. However, consumer now need to make additional API call. If the order service is unavailable, the consumer cannot retrieve the information. If 10 consumers react to the event, all 10 may call the order service, creating the additional load. Therefore, event notification reduces the event size, but it can introduce runtime coupling through the callback API. Okay. Next is event carried state transfer. The second approach is event carried state transfer. Here the event contains the information consumers require. For example, event type order created, order ID 501, customer ID C123, amount XY like 1000 rupees, status new. Now the inventory notification and analytics service can process the event without calling the order service. They may update their own local read models using the event data. The advantage is fewer synchronous dependency. The consumer can continue processing event when the order service is temporarily unavailable. But the events became larger and some data may be duplicated across services. We must also handle schema charges carefully. The decision depends on use cases. Use event notification when consumers only need to know that something happened or can safely fetch the latest data. Then use the event notification. Use event carried state transfer when consumer needs enough information to process independently. Avoid putting an entire database record into every event. Avoid putting an entire database record into every event. Include only the business data required by the consumers. Now let's see the choreography and orchestrations. There are two important ways of coordinating business workflows. One is choreography. In choreography, there is no central controller. Each service reacts to events. Each service reacts to events and publishes new events. For example, order service publishes order created. Payment service consumes it and publishes payment completed. Inventory service consumes that event and publishes inventory reserved. Shipping service reacts and begins delivery. This is similar to dance. Each participant know when to act based on what happened before. Choreography provides loose coupling and allow service to work independently. But when workflow becomes large, it can be difficult to understand which service triggers the next step. Debugging and handling failure may also become complicated. The next is orchestration. In orchestration, the central workflow component coordinates the process. For example, an order orchestrator may ask the payment service to process payment, ask inventory service to resolve the stock, ask shipping service to create a shipment, handle compensation if any step fails. The service don't decide the complete workflow. The services don't decide the complete workflow. The orchestrator does. This makes the process easier to visualize and control. However, it introduces a central coordinator that can become complex and must be designed for reliability. Use choreography for loosely connected reactions. Consider orchestration when the workflow has many steps, strict sequencing, and complicated failure handling. Many production systems use the combination of both. The next topic is order processing example. Let's connect everything in one complete example. A customer places an order. The order service saves it and publishes order created. The payment service consumes this event, processes the payment and publishes payment completed event. The inventory service reserves the products and publishes inventory reserved. The shipping service creates the shipment and publishes orders shipped. The notification service can subscribe to these events and keep the customer informed throughout the process. Each service owns its own data and responsibility. Services collaborate through event instead of creating a long chain of direct synchronous call. We can add a new fraud detection or analytics service later for subscribing it to the relevant events. Existing producers don't need to change. That is the real power of event driven architecture. Services become independently deployable while still collaborating through the business event. Let's quickly summarize. today's lesson. Event driven architecture uses business event to connect and coordinate services. Event describes something that has already happened. Commands ask particular service to perform an action, and message the package that transports an event or command between services. The event notification sends a small event and allow consumer to fetch more information. Event carried data state transfer includes enough data for consumer to process independently. Choreography coordinates services through event without a central controller, and orchestration uses a central component to manage the workflow. This completes part 1 of the event driven architecture, but one major challenge remains: what happens if the order service saves the order but fails to publish the event? How do we keep data consistent across different services? In part 2, we will discuss eventual consistency, the dual write problem, the transactional outbox pattern, change data capture, event versioning, event replay, production best practices. If this video helped you, please like it, share it, and subscribe to the Avinash Explains Tech YouTube channel. Also, tell me in the comment what you what would you choose, choreography or orchestration for an order processing workflow, and why. Thank you for watching. I'll see you in the part 2.